Hi, let's work in our last tutorial. So we're going to put into action all the skills that we have gained so far. So our last tutorial will be the flow about the square cylinder. Okay, so we're going to do some scale resolving simulations. Okay, so those models, but also we're going to do some state simulations to use as initial condition for the scale resolving. So the case basically we have it in this figure. Okay, so we have this domain. I already pre-manufactured for you the mesh, so you can download it. And basically we are going to have an inlet outlet. We are going to set up some periodic phases, you see here, and then your cylinder wall. Okay, and then the top and bottom will be slit walls. Okay, so the only wall, no slit wall, will be cylinder, and the rest no slit. Periodic phases, inlet and outlet. Periodic phases means that what is going on here, going out here, and vice versa. So this case has plenty of data. Okay, so you have here the dimensions of the domain. So if you want to use your own mesh, you can get it from here. Okay, so we have here our conditions, what we're going to do. So this is a Reynolds about 2200 thousand, and let's work it out. So in the course tutorials, this is 15. Okay, so you will have here, you have a lot of references, so you can download of them. This is one. So you have some experimental results, numerical data, and here you will have your case file. So we have the Fluent meshes, the Fluent cases ready to use, interpolation files. So I already run these cases, and these are the files that we're going to use to interpolate from a quartz mesh to a fine mesh, from one case to the other. So I have everything already preset up. Here we only have the case definition. Inside files, we're going to do some post-processing, and I like to use these files to do the post-processing. So we're going to see how to save the files automatically in while running, and then opening that using ParaView. And then here we have some Fluent settings, an output of a case time series, just to get an idea of the frequencies, everything, and well, the basic instructions that I show you. So we're download. Just if you're using Fluent 2020, download this one. Okay, it's ready to go, and we're going to work it out. Also have ready interpolation files. So we're not going to run the whole stuff, the whole 20 seconds usually I run this one. So I already have the interpolation files, so you can pass from one case to the others, and also download this file to do the post processing. So let's move to the first case. So in our workflow, we're going to start first with a steady simulation. Okay, to have an idea what is happening. Then that steady simulation, we can use it to initialize an unsteady simulation. Still, we're at the occurrence level, which we can move really fast there. We can use large times to get a lot of information, and after running that, we pass to the scale resolving simulations. Okay, so let's open the case. So you should have. By the way, just let me show you what we should expect here. So here we have a few cases. So we're talking about speeding your simulation. See that you can use within initialization and no initialization. So you will see that you can have the speed up of your solution when you start from initialization. At the end, you will get the same, but you can speed up the onset of your perturbation. Then we have different cases. Okay, we're working fine mesh and coarse mesh. So probably it's difficult to see, but you will realize that when you have your solutions, that the coarse mesh kind of does not resolve very well the vortex extraction you see here. And we can also study in the fine mesh the influence of a time step. So see that for our CFL1 and CFL10, and see what we have. Okay, so see that we have a good solution. However, when we look at the time series, we might see that one will probably overpredict or underpredict the forces, but doesn't mean that you cannot run LS with a large CFL number. It means that probably you are not into too much numerical diffusion. And then comparison between all the cases. So we go from DNS, LESS to DES, and then URANs. All of them are implemented in Fluent, and basically any decent CFD solver will have all this method. So DNS is laminar, no model at all. And see what is happening, that URANs are very good methods. We have seen the URANs and RANs. However, due to the 10 averaging that we're doing, you see that we don't manage to capture the vortex extraction. So it's very difficult to capture that one. So probably you will need to let it run for very, very long times and much finer meshes, okay? And even if you have something, you will see that some instabilities, they will also be damped very fast due to the 10 averaging. And here we have another view. So we're going to work it out, okay? Don't hope you have your cases. And your folder structures, after you download everything, you should have something like this. Okay, so you have here the meshes. Okay, so if you want to start from scratch, you have the quartz and fine meshes, so they are within the limits for the academic license. Then you have the setting files. These settings files, you can use it to set up automatically your cases. Okay, then you will have the interpolation files. Remember, these are solutions that are already run. Okay, so you have the interpolation, you can interpolate fast. Okay, so you have interpolation, quartz mesh, the RAN solution, okay, the URAN solution, and then the LESS solution. Then for the fine mesh, you will have the RANs, okay, and then the LESS. So basically what we're going to do, we're going to run everything at the quartz level. Okay, check everything, and then we interpolate that quartz solution from the URANs or the RANs to the LESS case. But here also you have the field that you can interpolate it and get a star immediately. Then you will have the inside files. These are the files that later we're going to open with Paraview to do the unsteady post-processing. So far within Fluent, we have been doing, let's say, a static post-processing, just one solution, but doing this post-processing is a little bit tricky, so I like to use Paraview, and to do that one I like to save the files in this format. You can also save the files in Fluent format, but I have found that this format, it takes less space and is easier to manage within Paraview. And finally, here you will have a folder called cases. In the cases folder, you will have, again, quartz and fine. And here we have the predefined cases, okay? Everything has been preset up. We're going to go through this. Okay, so download everything, have ready. So we start from quartz, RANs, then we move to URANs, and then we do fast LESS simulation here in the quartz, and then we move to the fine. Okay, everything just interpolating from one to the other. So download everything and let's get to work.